happened. I'm here to talk about Elasticsearch a bit. It's kind of an introductory talk, but I want to make it a bit more practical and talk about one kind of use case, which is searching and analyzing logs in real time, which is kind of...
Excuse me, can you present yourself first?
Yeah, I will. I will in a second. I just want to tell you what the talk is about first. Yeah, okay. Yeah, I hope it will be useful for you. So about me. This is me. This is my one slide. So I'm a search consultant at Sematext. I do search consulting, and also do training and technical support, things like that. I do some work in our products, which are basically about centralizing logs and monitoring things. In the backend there's Elasticsearch at one point. I also just finished a book called Elasticsearch in Action. It's currently in production. I can't wait to see it. For now, it's still in sort of early access. And we have two of them. I know. I'll get there. Everyone's getting ahead of me. Anyway, so this is a discount code if you want to get it with 40% discount. If you want to get it with 100% discount, our sponsor, Netopia, right? They bought 2 books for this event. So if you want to get it, yeah, it's because it's not really paperback. It's about 1 month until it will be finally paperback. So yeah, it will be electronic. So first 2 questions, you'll get the 100%.
What's the question?
So please give. Sorry?
What's the question?
Yeah, but
what's your name?
What's your name? It has to be a relevant question, okay? Don't cheat. So yeah, because being an introductory talk, it's kind of hard to figure out where to focus. So questions will really help me understand where I should spend more time and where I should spend less time. Talking about time, it's going to be a bit less than we initially expected. So yeah. I should close this window, but I don't know how. Alright. Alright. So yeah. So the structure of the talk first. The idea is Elasticsearch is a search engine, for those of you who don't know. By the way, who's like a developer? Can you raise your hand? Okay, cool. Who did work with Elasticsearch? How about, keep your hands up, how about Lucene or Solar? Alright. Who knows what Elasticsearch is about? Okay? Right, so Elasticsearch is a search engine, and it's good at indexing stuff. So you can like search things really fast, and you can do data analytics on that subset of things that match your search. So it's kind of for this use case of real-time search and analytics. So, and its primary, I guess the most popular use case for it is searching and analyzing logs. So this is what I'm going to talk about. And the talk is going to be I'm going to talk about 3 things. So one is how to put your logs in Elasticsearch. One is about how Elasticsearch does your searching and analytics and how you would scale it out, and a couple of best practices here and there. And then how you would visualize the data once it's in. And I would like to take it sort of upstream by looking first at visualizing, to sort of look at the shiny graphs and things like that and know what we are working towards. And then I would want to spend more time talking about Elasticsearch, because that's what the goal is. And then finally a bit about one of the many logging tools that can write your logs to Elasticsearch. Alright, so I'm going to start with Kibana, which is kind of the go-to visualizing tool for Elasticsearch. Like if you just don't know where to start, if you have a bunch of logs and you found a way to throw them into Elasticsearch, Kibana is a good place to start. It's actually very powerful. I just downloaded the kit and untarred it here, and you can configure it. It's a YAML config file. You point it to your Elasticsearch instance, and that's pretty much it. I have Elasticsearch started here with a bunch of Apache logs already indexed. So yeah, I'm gonna try and show you a few things that you can do with Kibana. Right. Now actually I have to start it first, right? It's a Node.js app. I don't really know anything about Node.js. Don't know much about Kibana either, but yeah, I'll show you like the shiny stuff. It is shiny. It doesn't find anything. It doesn't find anything because it searches in the last 15 minutes by default, and I don't have anything in here from the last 15 minutes. I have something from this here at any point. Yeah, there you go. I have something here. And you can zoom in the graph. I want to see even more. Oh, come on. You've got to be kidding me. Yay! It's a really short time span, but yeah. So yeah, this is like how many logs I have every 82 milliseconds, if that matters. And here are the logs themselves. So what you can do at this point in this interface is you can search. For example, let me search of people that are using Macs, right? So I'm going to search for Macintosh. What? This wasn't supposed to happen. What the actual? Alright, let me start over again. Sorry about that. I did it like 100 times and it never happened.
There's a typo, maybe?
No, it's not.
Macintosh.
Macintosh, that's true, it is a typo, right. Okay.
No.
Isn't Elasticsearch supposed to help you with typos?
Yeah, it does. That was actually going to happen later, but I'm going to show you how it does that. You can do like a fuzzy match, and you can say, give me like 1 edit distance away or 2 edit distance. An edit distance means I'm going to delete a character or add a character. So if it's Macintosh, I'm guessing I did a typo here. So what if I did a typo with like 1 letter off? So we will search. The fuzzy search will take longer, and my laptop is very slow, but it actually finds Macintosh, right? If I do like the real thing, it will work a lot faster, and it's not because it's cached; it's just a lot faster. And I will explain a bit later, hopefully, if I have time, why. And you can also have things like wildcard search. So you see now Mac matched as well, and yeah, things like that. So this is search. This is like if you want to grab your logs, if you have like a terabyte of logs, you can index it in your Elasticsearch cluster, and you can search it in, provided the cluster is big enough. But it's actually really, really, really fast at doing the search stuff. So, okay, visualizing. So I'm going to start with a bar chart, like the one in the main UI. So this is 1 bar because I have nothing on my x-axis, but you can choose what you want on your x-axis. So I want a date histogram on the timestamp field. So now if I click play, hopefully nothing will crash again. Okay, so now I can see pretty much what I saw before, like the breakdown of how many logs I have in there in each time interval, again 82 milliseconds. But this is not necessarily interesting. Like if you see a spike in your logs, you know there's like extra activity there, but you don't really know why. So maybe what you want to do is to sort of dig deeper. So you can nest aggregations in this way. This is so what Kibana does is queries Elasticsearch, okay? And this sort of graph is generated by an aggregation. So it basically says, for all logs that match this time frame, because it's just start here, it's not Macintosh or anything like that. I could add any filters. Just go through all the documents and figure out which one falls in which bucket of 82 milliseconds. And it returns you counters. Like for this particular bucket, you got 97 logs and things. So that's how the graph is built. But you can also have, for each bucket, you can have like a sub-aggregation, and you can break things down even further. So in this case, let's say I want to know whether this is genuine traffic that's causing the spike there in the end, or it's actually some error and people like trying to access my website and getting errors all the time. So I'm going to add a sub-bucket, and I want to split the bars by response Okay, this is a terms aggregation because I'll be looking at terms, like the actual words within there. And words in this case will be my error codes from Apache. So the field will be response. And if I hit play, hopefully, there you go. So now I have the breakdown for each bucket of what response code is in there. So most of them are like 200, but there are some redirects and whatever these codes mean, like 404. Okay. So in this case, it's actually genuine traffic. I have more 200s here, so I don't know, kind of makes sense to me. And this is pretty much all the shiny stuff I will show you. If you have any questions at this point, it would be a good start to win 2 books. No? Okay. This is depressing. Okay.
So, is the field there, you have like a drop down, is that populated by introspection? Does it automatically detect the schema of the data that you have?
Yeah, because you can use the API to sort of get the schema from Elasticsearch, and so you can get the fields you want.
Is Elasticsearch automatically detecting the schema of the logs? Or
Yes.
do you have to, use like a pre-filtering regex?
Well, by default, yes, it does that. So if you, it does a lot of stuff out of the box. Like for example, if you have nothing in there, just have Elasticsearch fresh just started, and you put a log in there. That one log has to go to an index, which is kind of like a database. I was going to say that later, but I think that's a good point. So you have to put that in an index, and you have to put that index within the index. You have to specify a type, which a type is kind of a logical structure which holds your schema. Okay, so which fields are in which are in your documents. So if I put my first Apache log, which has a timestamp, a response, and whatever it has there, and it has no idea, okay, what's this index name? I don't know. So it will create the index automatically, and it will try to figure out, okay, so what do you have here? You have response code that's 200, so I'm gonna assume that it's an integer. And you have a user agent field that looks like a string, so I'm going to assume that's a string. So it will append your mapping automatically. In production, you don't really want to have that because you might have a situation, for example, where you have what would normally be a string field, and just by accident there's a number in there, and it says, okay, it's a number. So now all subsequent strings will fail to index because it thinks it should be a number. So normally you would have the schema defined up front, but yeah, you don't have to. And you can always like add things to your schema. Is there any other question?
Semantic search, it's a payload?
I don't know what semantic search is. I just feel stupid after Alex's presentation. What do you mean? Can you elaborate?
Yes, I have an index.
Yes.
Organized by some concept, and when search, I have a correspondence between my search phrase with this ontology, say, this concept, yes. And example, I try to find out library,
Okay.
and return me bookstores.
Yeah. Well,
because there are in same group of semantics.
yeah.
Something about books.
I think I get what you're saying. You basically have that. It's not like out of the box, as in you're indexing stuff and you're searching for books and it automatically knows that you're talking about library. But you can do that, and I will talk a bit about how text is processed later. But basically, you can say, if you find the word book, then also sort of index library. And then when you search for library, it will find your document. So you can have things like synonyms, stemming, yeah, things like that. Yes?
About Kibana, let's suppose that I'm using something like log4j in order to generate my logs.
Okay.
But I might be using something else.
Yeah.
Is Kibana going to automatically detect which is the date, which is the return code, which is the response code? I suppose we have to tell it somehow. Which is what?
Yeah, you have to tell it, like what's the timestamp there, like on the graph. But it will.
Regex or something.
Sorry?
I suppose we have to specify the regex. Or
Ah,
something.
you mean like you have like one great string and you want to index it, and how
Yes,
does
for
it know
example, if
which?
I want to filter by date, how does it know which part of that string is the date?
Okay,
Is
so
it automatically
there are two
detect-
things here, and one is about indexing your logs. So if your log is like one great string, you have to parse it, and then because the documents that end up in Elasticsearch are structured documents. So if you have just one string field that contains all your stuff, then you can't really search. Except you can search for keywords, but it has no idea where in there is the timestamp and things like that. But what you normally do is you would parse the data first, and then you would have the fields, and you would construct a JSON, and then that JSON would be indexed in Elasticsearch.
So that's something that you have to configure in order to match the format you're using to print in your logs.
Yeah, it's something you have to do before indexing, and I will show you a bit of that in the end, like how you can do that with our syslog in this case. But yeah, there are lots of tools that can parse your logs and then, so that they are structured by the time they get to Elasticsearch. And then when you do the search, then Kibana tries to guess, because in the schema it knows that at timestamp there is actually it's a date field. So when you want to specify a date field there, it's like, isn't timestamp? So yeah, it does that guessing for you in terms of UI. But UI, you can build any kind of UI on top of the Elasticsearch API. This is just like the easiest one to use. You just install it and have a couple of keys.
So as far as I understand, this is something kind of on top of Lucene, for example, because it has fields, and if you just search.
Yeah, Elasticsearch is built on top of Lucene. So Lucene does the heavy lifting for Elasticsearch. Yeah. Elasticsearch adds up the sharding and all things that I hope I will have time to talk about. Right. So let me move on just a bit. Actually, at this point, I want to talk more about Elasticsearch itself. So let me go back to the document itself. So the document in this case.
I show the source. I want to show the source.
I suck at UIs. All right, here you go. So, right. So my document looks like this when I index it. Right. It's a JSON document. It has fields and values. For example, I have this agent field, which is a string that looks like this. It's a lot of escaping, so it looks pretty ugly, but yeah, bear with me. This one's easier, verb get. Okay. So yeah, this is how my documents look like, and I will send them via HTTP normally. There are like lots of clients and things like that. I would send them to Elasticsearch. And Elasticsearch by default, let me make sure I don't skip anything. Right. So Elasticsearch by default, it indexes your stuff, as I said, which will enable the fast searching, and it will also store the data, as you can see here. And this is basically all this low-level work is done by Lucene, which is the search library on which Elasticsearch is built on top. So when you send a string like this one, like the user agent here, what it does first by default is to analyze the string. So it says, okay, this is my string. I'm going to break it into what I consider to be words, and this is configurable. You can skip the analysis process altogether. But by default, what it says, it breaks it down into Mozilla, Macintosh, Intel, blah blah blah, all those words here, and then it builds an inverted index. And what an inverted index is you have a mapping of terms like Mozilla and Macintosh and Intel and so on, and the documents that contain those terms. And so when you search for like Macintosh, you will just go through the term dictionary and it will find the Macintosh, and it will automatically get all the documents that match Macintosh. So it will be, that's why search is so fast. But from this sort of structure, an inverted index, it's complicated to get back the whole agent. So it has to also store the field. Now by default, Elasticsearch doesn't store any of these fields like message and things like that. Instead, it stores this underscore source field, which is kind of a predefined field Elasticsearch uses when you send the JSON document to it, it says, okay, I'm going to make a Lucene field name underscore source, and I'm just going to store it. I'm not going to index it. I will just index all those fields within it, but I will just store source. So you can get the source back. You can reindex documents if you want to change your mapping and things like that. All right. If you have any questions at this point about indexing, storing, all right. And another predefined field is underscore all, and I'm going to attempt to use the UI again. So when I search like this, just Mac here, it will automatically search in all fields. And it does that by having a predefined field called underscore all, like underscore source is a predefined field, where everything is indexed. So that's why when I just say Macintosh, it will just search through everything. Now, if I know in which field to search for, like agent, I would just say agent is Mac something, and it will find the same results. But anyway, the point is you can search in specific fields, and you also have this underscore all field in case you don't know which field you want to search in. And another thing to think about when you have this underscore all is, in this case, I have a message field which already contains everything. So it's kind of redundant. You might as well disable it. Alright, so now when I'm searching for something, I might get back like 1 million hits. Like, I'm not sure where's the hit count here. 394. But it doesn't show me all the 394. It only shows me, I hope it's not infinite scroll. Yeah, it is infinite scroll. Well, it pages and, you know, it just gets like 20 documents and then the next 20 and so on. So it has to rank the documents, figure out which one of those 397 to show me. So by default, you get the first 10 documents, and they are filtered by score. And this score is something highly configurable. By default, it's just TF-IDF. Does anyone know what TF-IDF is? Right. So it's something based on frequency. So like if I'm searching for Mac and Mozilla, you know, if Mac is highly frequent, first of all, if I'm searching for Mac and Mozilla, where was I going? Okay, first of all, TF-IDF comes from term frequency, inverse document frequency. So term frequency counts. So documents having more occurrences of Mac and Mozilla will rank higher than those who have less mentions of these words. But inverse document frequency means that if Mac occurs like in all documents or in very many documents, then it's not really relevant. If Mozilla occurs more rarely, then that is more relevant. So the score, the weight of the score from Mozilla will be higher than the one for Mac. And you can do lots of stuff with this score. You can change the scoring algorithm. You can sort of add things up to your score, things like values from your documents, like the number of likes. You can do things like if documents are older, sort of lower the score to make the fresher stuff rank higher and things like that. But with logs, you don't really care about scoring because normally you will just sort by timestamp, which is exactly what is shown here. It's sorted by time. And to sort by time, it's kind of a more complicated thing because you know, the scoring, which is based on frequency, that's pretty easy because in the term dictionary, where you have the terms and the document IDs that match your term, you also have the frequencies. So for each document that has that term, you already have how often that term occurs. So already when you're searching, you can really quickly sort of rank the documents to return the top ones. If you want to sort by timestamp, what you have to do is to take all the documents that match and then look for every document what the timestamp is in order to sort. And again, this is something that the inverted index is not really good at because it has a mapping of the term to the document itself. And what we want is the document, the ID of the document that match our query to get the timestamp in order to sort them. So you can obviously take that sort value from the source field, which means going to disk for every document, getting the source field, parsing it, going to the timestamp field, which would be extremely slow. So what happens by default is, the first time I'm searching for timestamp is, okay, I need a mapping of IDs and timestamp values. So it takes all the documents from my index and it builds a column-oriented data structure in memory where it says these are the IDs and these are the timestamps. And this is called field data, and it's very, very fast once it's loaded. So yeah, first search might be slower, but then you really quickly will do the lookups. The downside is you might not have enough memory to load all the documents' timestamps into your JVM heap. So in order to do that, there's a structure called doc values, and that is a similar structure to what field data is, in that you have a mapping of IDs to, actually the way I did it is the other way around, but anyway. You have a mapping of IDs to the values, but it's built at index time, so when you index your document, and it's stored on disk, mostly. So with doc values is something that you will normally use for logs, because you don't really want to load everything. You normally have like lots and lots of logs, and you don't have the memory to load that. And it's only a fractionally smaller in terms of performance than the in-memory field data cache. So this is something to look for. Right. I'm gonna stop.